Hi, so for today's notes, what we're going to be doing is we're going to be talking about transformations of our linear functions. A transformation of a function maps each point of its graph to a new location. A transformation that shifts the graph of a function in the same direction, horizontally, vertically, or both. Okay, so we're going to focus just on translations, translations. A shift of each point of a graph to the left or to the right is a horizontal translation. A shift of each point of a graph to the up or down is a vertical translation. So just again, to reiterate what we're doing, translation, it's a translation shifts each point of the graph in the same distance, horizontally, vertically, or both. Now the horizontal translation, the way it's going to look in our linear functions is it's going to take that f of x and add x to it within parentheses, okay? And so what's kind of crazy about these horizontal translations is the shift is actually in the opposite direction. So when I see that x plus k, our shift is going to be to the left. And then for g of x equals f of x minus k, we will shift right. And so what we have right here is my point shifting to the left, okay? So this is a horizontal translation, how it shifted left. Now vertical translation, notice how when we compare both horizontal and vertical, the adding the k is on the outside of parentheses, okay? And this one's at least nice and easy. It's not the opposite. So we're going to shift up. Then when we have g of x is equal to f of x minus k, that'll be a downward shift, or shift down. Okay, and so when I take a look at this picture for our example, here's my starting point, and then we have an upward shift, okay, if it is plus k. Let's go ahead and practice some of these. So for example number 1a, g of x is equal to f of x plus 12. This is going to be a move up or shift up 12. For b, this is going to be a move down 7. For c, this one is going to move, and then this one, remember, since it's inside parentheses, it's the opposite, so we're going to move left 8. And then this last one, again, it's all inside parentheses. We move right 14. So again, the horizontal translations are opposites. This is something that you definitely need to memorize. Maybe even make note cards for yourself to help you remember. Okay, so problem number 2a, where it tells you to translate from f of x to g of x. Okay, so if this is f of x, we're going to figure out how does this shift and change to g of x. Okay, so I'm going to take this, and doesn't it, it looks like it just moves upward to g of x. So this is going to be a move up 3 units. Okay, we'll do b next time I see you in class. All right, let's go ahead and flip these over. So right now we're going to briefly discuss parallel lines. Parallel lines have the same slope, but different y-intercept. Okay, And so we'll go ahead and try number 3, where we will describe the transformation from 2x plus 2 to h of x equals 2x minus 4. So they have the same slope, so we know they're parallel lines. Okay, and so something to think about with this problem, I'm going to quickly draw a coordinate plane, and 1, 2, 3, 4. There I have negative 4 as my y-intercept. And then for the first one, my g of x, so I can kind of label this one's g of x, the other one's h of x. The transformation was, this was a movement from g of x down 1, 2, 3, 4, 5, 6 to h of x. So we'll just go ahead and write down that we move down 6 units. Okay. Now, example number 4. We'll do this one the next time I see you in class. Let's go down to number 5. Number 5, the following graph shows the function f of x and f of x plus k. F of x plus k is the image of f of x after a translation of k. We need to know what is the value of k. So all we're going to do is go from f of x to f of x plus k. So we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So k is a downward shift of 10. So k is equal to negative 10. And so we'll go ahead and maybe squeeze in number 6, since these notes aren't too long yet. Two linear functions are graphed on the same coordinate plane. The graphs of the functions are parallel, where f of x has a y-intercept of 0, 4, g of x has a y-intercept of 0, negative 2. How did the graph translate? Okay, so I'm going to draw that coordinate plane again. If f of x, 1, 2, 3, 4, has a y-intercept of 0, 4, g of x, 1, 2, has that y-intercept of negative 2. How did it translate? And this is where we can say move down 6 units. Write an equation relating g of x to f of x. Okay, so we're relating g of x to f of x, so this is going to be g of x. Its equation is the same as f of x. We know it has the same slope because in our story problem they talk about how they're parallel. Since it went down 6 units, it's minus 6. So that's the equation. Okay, that's it for these notes. How nice, short and sweet, and we'll just touch up and enter in what we didn't do in notes today. All right, may the force be with you.